Hi there, Gina here. Today I'm going to show you how to use the area box method to fluently multiply two-digit numbers. And I want to start off by talking to you a little bit about the way you learned it. You and I learned it probably in the 70s or 80s or 90s. And we learned to do standard algorithm. The kids these days call it turtle head method and that kind of thing. But the way you and I did it was 86 times 33, and we would multiply 3 times 6 is 18, and 3 times 8 is 24, plus 1 is 25. Then we were told to put a 0 here. We call it the placeholder. Here's the problem. That's something that a lot of kids forget to do, and let me tell you why. They don't understand why they're putting a placeholder there, because they don't understand that they're not multiplying 3 again by 86. They're multiplying 30 by 86. Therefore, that's why the 0 goes here. It's 30 times 86. 3 times 6 is 18. 3 times 8 is 24, plus 1 is 25. And then you add them up. And the answer is 2,838. And now that's the way you and I learned it. And so a lot of you at home get very frustrated because you see the things they're bringing home and you don't understand it. It doesn't make any sense to you. And I want to help make that's my whole purpose of this YouTube today, is to show you that actually what you're calling the new method is really not a new method. It's just a different way at looking at what you're actually doing. Because even though you might see 86 times 33, it's very important that your child sees that it's 80 plus 6 times 30 plus 3. And in this case, you'd understand that 3 multiplies by 6, then by 80, and then 30 multiplies by 6, and then by 80. And if we did that right now, 3 times 6 is 18. 3 times 80 is 240. I'm sorry, I'm using my hands to hold this camera and that. You get 258. Well, look over here. That's right. When you multiply 3 by 86, you got 258. Now you're going to take your 30 and multiply it by 6. 30 times 6 is 180. 30 times 80 is 2,400. And you get 2,580, which is exactly what you got when you multiplied here. The only difference is lots of times your student, or maybe even you, didn't really know why you're putting a placeholder there. But now you do. And then you would add 2,580 plus 258, and you would also get 2,838. But that brings me to the box method. And I know a lot of you do not like the box method. You don't understand the box method. So I'm going to try to explain to you how the box method works. So if I took another number, let's say I took 56 times 39. Okay. And I'm going to use the box method now. And I'm going to make myself a box. And now I'm going to break that up. That's why we work on place values so much. That's 50 plus 6. And I'm going to multiply 56 by 39. And notice that I made this larger so that we could kind of know what goes inside each box. It's going to be 30 times 50 is going to be larger than 9 times 50. But let me go ahead and solve for each box. 30 times 50 1,500. 30 times 6 is 180. 9 times 50 is 450. 9 times 6 is 54. Now, all I have to do is add up. I could add across if I wanted to, or I could add up and down. Doesn't really matter. So I'll do this one, which would give me 1,950, because 1,500 plus 450 is 1,950. 180 plus 54 is 234. 4 plus 0 is 4. 8 plus 5 is 13. 1 plus 1 is 2. I add that to what I had here in this column. My answer is 2,184. That's the area box method. There are more ways to multiply fluently, and but the reason why I showed you this is good for students to see visually what they are doing. What are they multiplying? What does that number look like? Also, for those students who have messy handwriting and it's hard for them to line up their numbers and add correctly, this is a really good method to use for those students. The ones who are visual learners, the ones who maybe their fine motor skills are not quite as good, or maybe this is the way their brain works. What I'm telling you is there's not a wrong or right way to do math. Well, yes, there is, but I mean, to which method you use. It's the method that works best for you. And this whole thing is meeting the needs of each individual child. And I wish I had had more of this when I was a kid, because lots of times I didn't understand math, and I was just told, well, this is the way you do it, that's what you do. But now I can look at this and understand what I'm doing and why I'm doing it. Until next time.